Today we're going to look at what makes a good conductor. And a good conductor is a material that allows electrons to move easily from atom to atom. And the electrons that move are the outermost electrons around the atom. And these atoms that move are called the valence electrons. And of course, when you move electrons around, what you're really doing is creating a current. So we're going to look at a measure of how easily those electrons move. It's called the conductance. And the conductance is abbreviated with an uppercase G. And the units for conductance are Siemens uppercase S. So conductance actually is not very commonly used. More often, we're going to be looking at resistance. And resistance is the reciprocal of conductance. So resistance R is the reciprocal of conductance G. So G is equal to 1 over R. Resistance is the opposition to current flow, the opposition to those electrons moving from atom to atom. And that is measured in units of ohms, and we're going to abbreviate that with the Greek letter omega. So the resistance is equal to rho L over A. So R we saw, that's the resistance, that's measured in ohms. L is simply the length, that would be in units of meters. And A is the cross-sectional area, that is in square meters. So if you have a wire, the longer the wire, the more resistance. If you look at a cross-section, the thicker the wire, the less the resistance is. And then we have this other variable called rho, which is called the resistivity. And that is the constant that depends upon the material that we use to make the wire. So different materials fall into different categories. They might be insulators or they might be conductors. Conductor, of course, as we saw, allows the electrons to move freely from one atom to another. An insulator makes it very difficult for the electrons to move. And a semiconductor lies somewhere between those two. And these semiconductors are useful for transistors and diodes and things like that. There's also something else called superconductors, and we'll get to that in a few minutes. The conductors are the ones that we're going to be concerned with, and there are 4 different materials that are commonly used as a conductor, and they are copper, aluminum, gold, and silver. And a lot of people will ask the question, which material makes for the best conductor? And usually what they mean by best conductor has the lowest resistance. So we have to look at the resistivity of each of these materials. So here's a chart showing the resistivity. Remember, resistivity, you want a lower number to be a better conductor. So you can see copper is 1.68 times 10 to the minus 8 ohms per ohm meter. And aluminum is 2.65 times 10 to the minus 8 ohm meter. Gold 2.44 and silver 1.59. So the lowest one there is silver, which is probably a surprise to most people. A lot of people think that gold is actually the best conductor, when in fact it's silver. And you can probably guess why silver is not widely used, and that is because of cost. Copper, of course, is much less expensive than silver. So copper is a very, very common conductor material. So what parameters are we concerned with when we're choosing a material to be a conductor? Well, we need something that's ductile. In other words, something that can be pulled into the shape of a wire. We need something that's fairly inexpensive. We don't want to spend a lot of money for it. And we would like something that is very inert. So again, we don't use silver because it's expensive, but you may see, particularly with connectors, they are gold or gold plated more likely. And that's supposed to be kind of the top of the line. And that is not because the resistivity is low, but rather it's very, very inert so that it will maintain a good connection. It doesn't oxidize and increase in resistance because of the oxidation. So it will be very stable. And I think there's a marketing aspect to that. People associate gold with high quality. It's high cost, and a lot of people think, well, if it costs more, it must be better. But again, it has a use for contacts and connectors and so forth, but is not really the best conductor. The ductility is a very important parameter when we get to that other topic that we mentioned, superconductors. So what is a superconductor? A superconductor is a material that has zero resistance. And I don't mean very low resistance, I mean exactly zero. No opposition whatsoever to current flow. The problem is most superconductors will only superconduct at very low temperatures, approaching absolute zero. So that's one problem with superconductors. And the other problem is most superconductors are some sort of ceramic, and ceramic is not very ductile. So it's very difficult to form the superconducting material into wires. So that's a little preview of what do we mean by a good conductor and what parameters go into making a good conductor. So stay tuned to Mark's Tech Talk for other videos relating to electronics technology. Thank you for watching.